Hello, everyone, and welcome to the From CloudWatch Alerts to Resolution Agentic AI for AWS Ops webinar. My name's Bennett, and I'm with NeuBird AI. I'm a solutions engineer and previous site reliability engineer. And today I'm joined by Kishore from AWS.
Hey everyone, this is Kishore Vinjam. I'm a principal solution architect at AWS based off Raleigh, North Carolina. I have spent 7.5 years at AWS, specializing in cloud operations in general. So that includes governance and observability. So I work with enterprise customers and cloud ops partners worldwide to build scalable, secure solutions that optimize operational efficiency. I'm particularly passionate about how AI-driven operations and agentic AI are transforming the operational resilience and reducing the mean time to resolution. Looking forward to share more insights today.
Thanks, Kishore. Let's take a look at the agenda. So today we're going to walk through a few different things. On the AWS side, we're going to look at CloudWatch and what it means for enterprise observability and scale, a blueprint for how to actually do that. We're going to get a CloudWatch demo, and then we're going to turn it back over to NeuBird's side, and I'm going to give you a brief overview of Agentic AI SRE and what NeuBird has in the space. And then we'll wrap up with the conclusion. And I invite everyone to ask questions throughout this presentation because questions will end at the end of the presentation. So back to you, Kishore.
All right, thanks, Bennett. So let me paint a picture of what enterprise observability really looks like today, right? So we are talking about over 100 plus AWS accounts spread across multiple AWS regions, and then thousands of microservices talking to each other, and petabytes of telemetry data. Yeah, petabytes. Yeah, and this is like every single day, right? And now this creates three massive headaches. The first one is being the fragmented tooling. So you got one tool for logs, another for metrics, a third one for traces. It's like trying to solve a zigzag puzzle when the pieces are in different rooms. And the second one is the cost explosion. So your observability bill is growing faster than your actual infrastructure. I guess most of you relate to this one, right? And then the third one is the alert fatigue. So your on-call engineers are getting 500 alerts a day, and somewhere in that noise is the one single alert that actually matters, right? So this isn't just inconvenience anymore, right? So it is a business problem, and that brings me to my next point. When observability fails, especially when observability fails to scale, the consequences aren't just technical, right? So they are business critical. So your mean time to resolution goes up, and you're spending hours just figuring out which account to log into, and let alone fixing the actual problem, right? And then the alert noise becomes unbearable, right? So your Slack channels look like a fireworks display, and nobody knows what's actually important anymore. And then the data silos everywhere, which basically, if your logs are in one account, metrics in another account, and have a good luck correlating anything during an instant or that happens at 3 a.m. So actually, let me ask you something, right? So how many of you know the exact dollar cost per hour of downtime for your organization? So from my customer conversations, most people don't have an answer for this. So let me share some numbers that might help you justify your next observability budget request. So for 90% of our enterprises, downtime costs anywhere from $300,000 per hour, right? So it's not per day, it is per hour. And 41% of the enterprises, we are talking about 1 to 5 million per hour. So this is not counting the reputational damage, the current churn, or the delayed feature releases while everyone's are firefighting. So suddenly the observability investment doesn't look so expensive, does it? So now here is where most organizations get observability wrong. So they start at the bottom of the pyramid and never make it to the top. They obsess over CPU utilization, network throughput, disk I/O. But don't get me wrong, like these are important, but here is the truth, right? So your customers don't care about your CPU utilization. They don't care about if your database is at 80% capacity. They care about one thing, right? So does your application work? Is it fast or is it reliable? And that's why business outcomes sit at the top, right? So here things like customer engagement, revenue per transactions, user satisfaction. And so this basically, let me give you a real example, right? So at Amazon.com, what do you think our most metric is? Is it CPU, latency, or the error rates? Absolutely not, right? So it is the orders per minute that happens. So because at the end of the day, that's what matters to the business, and that's what matters to you as a customer for Amazon.com. All right. So how do we actually solve this? So here is the blueprint, right? So this is three foundational pillars that work together. The first pillar, multi-account and multi-region foundation. This is about breaking down the silos, centralizing logs, having a unified metric collection, and distributed tracing, all across your accounts and regions. So this is like having one pane of glass instead of 10 or 100 different dashboards. And then the pillar two is intelligence layer. This is where AI comes in, right? So anomaly detection that actually works, wherein the high cardinality analysis without exploding your metric count and automated correlation. So you are not playing a detective at 2 a.m. in the morning, right? I will talk about this much more in detail in the upcoming slides. And then the third pillar is the operational excellence. So taking those insights and turning them into action. This is where the tools like features like CloudWatch investigations for root cause analysis, application signals for automatic instrumentation, and specialized insights for containers, databases, and Lambda comes in place. And these three pillars aren't independent, as I said earlier. They are an ecosystem, right? So the foundation gives you the visibility. The intelligence layer makes you proactive instead of reactive. And the operational excellence turns insights into an action. So while pillar one sets the foundation needed for scalable observability, pillar two and three are further complemented by partner tools like NeuBird, which is an AISR agent that transforms CloudWatch alerts into autonomous incident resolutions and deliver actionable fixes without manual troubleshooting. So let me take a step back and show you the scale we are talking about here, right? So this is just to give you a picture on Amazon scale or Amazon CloudWatch scale. So every month, CloudWatch process 20 quadrillion metric observations and 13 exabytes of logs, 455 billion traces, and 861 million CAN reruns. So now I know you probably thinking like, what is this even a quadrillion means, right? And that's a fair question. And if you counted one number per meter, 20 quadrillion meters is about 2 light years, right? So that's pretty much like halfway to the nearest star. And here is the thing, right? So we use CloudWatch to monitor CloudWatch. At Amazon, like we standardized on CloudWatch for all new workloads because it handles the scale reliably. So if it can handle our scale, I'm sure it can handle yours as well. All right. So you're probably thinking this all sounds great. Kishore, how do I start or where do I start? So now let's dive deep into the technical implementation, right? So the first pillar of our blueprint is breaking down account boundaries, and it starts with centralized logging. So in enterprise environments with hundreds of AWS accounts, logs are scattered everywhere. Teams waste hours jumping between accounts. The teams waste hours jumping between accounts, trying to piece together what happened during an incident. So you can't see the full picture of a distributed transition that spans multiple accounts and regions. So in reality, the current landscape resembles something like this, right? So we have got AWS services like CloudTrail pumping out massive amounts of telemetry data, be it logs, metrics, traces, audit trails. It's happening all day and every day, right? And this data gets scattered across multiple storage systems. It's often duplicated in different formats because different teams need it in different ways. Then you have like three completely separate worlds living in parallel universes. So your security team with their SIEM tools hunting for threats, and then your observability team with their APM tools chasing performance issues, and then your audit team with their compliance tools tracking policy violations. Now here is a real nuance, right? They're often looking at the same event, but they can't see what the other team sees. It is like three people describing an elephant while blindfolded. One feels the trunk, one feels the leg, and one feels the tail, and nobody realizes they are looking at the same animal. All right. So the question is like, can we blur these lines between the teams? Yeah. So the answer is absolutely yes. And that's exactly what I'm going to show you next. And let me walk you through CloudWatch, how CloudWatch is actually becoming the unified foundation. So if you have followed the launches of CloudWatch during reInvent, I'm sure you heard quite a bit about CloudWatch Unified Store. This is not necessarily a single feature. This is group of things we added together based on our customer feedback to make the CloudWatch the unified foundation. So starting the collection part, CloudWatch now supports collecting logs from third-party tools like Okta, CrowdStrike, and so on. And these are the managed sources where the conversion mapping is already taken care. You just need to enable them to start collecting in the format that you need. And in the formats that are preferred for each individual teams, right? So something like OCSF, Open Telemetry, and so on. So if you're not familiar with OCSF, it is the format that security teams are aiming to standardize the logs on. So you can also centralize the logs to a location of your choice. So from multiple accounts and regions. So I'll show these features in a demo, all these features in a demo in a bit. And then there is this data can now be made available as a part of part of S3 tables. And this is an option for the customers. They can choose to do that. And this allows customers to query the data from multiple tools, be it from Athena, Amazon Athena, or SageMaker Studio, or any tool, or in any partner tool or custom built tool that is Apache Iceberg compatible, as the S3 table provides the endpoints. Right. And the best part is like there's no additional charges for most of these features, be it like pipelines to convert the format or optimize the data or log centralization or telemetry enablement and even the S3 table creations, right? So so these all are provided as a option within CloudWatch for no additional charges. All right, so with that, let us see the features in action. Okay. All right. So I will be switching between multiple AWS accounts here. So since we are talking about multi-account environments, so this is on my management account where I will be delegating one of the accounts as the monitoring account for observability purposes. So in this case, it is the account that starts with 345. I'm going to switch to that account since this is configured as my delegated admin account. And this is where I'm going to centralize my logs, enable the rules and whatnot, right? So this could be more than one, but potentially here, if I go back to the settings in the organization, I would be able to enable the centralization rules, right? Like the centralization rule is basically the way for you to define like accounts, like be it on account level, organization level, or organization unit level. I want to collect logs from so many regions into one single location, right? So that's how what you define as a part of the centralization rule. So here I'm configuring that like entire OU from US region should go into the destination account, and there is this backup region option, which comes with an additional cost. But this comes into the use case requirement, right? So if you need it, you probably would enable it. And then also you could specify you want to copy all the logs or specific to certain logs. And then in this case, I'm just picking log groups with AWS Lambda, and then you could specify the encryption options, right? So it could be an encryption key in the destination region, or it could be encryption key in in the source. Like you could define that configuration in there. So if you look at here, right? So this is basically like I enabled a rule, but I'm switching to a rule which I already have it running for a while here. So which gives me some meaningful logs. So this is the one with VPC flow logs that has log collection enabled at the organization level. So if I and if or it's not only VPC flow logs, all the logs, right? So here I'm looking at an application log. So if I actually go back a little bit. So if I look into the logs here, right? So the application log that I have, it has this account name and the region added, right? So this is coming from a different account that's starting with 108, right? So that's how the log collection happens. And then the once I have these logs collected, right? I also talked about converting this into a format of design, right? And then I talked about 3P tools, 3P tools that are listed out here. So in this example, I'm walking you through the VPC flow logs. So I wanted to convert these VPC flow logs into OCSF format. That's where basically I'm creating a pipeline, which is part of the CloudWatch now. And I can select for my VPC flow logs, use the OCSF processor, and this is the mapping that AWS provides out of the box, right? And once you select those, you can also add additional processors if you want to optimize the data that's being collected, right? So if you want to remove some of the events that you could do right from there, right? Once you configure this, like yeah, you can and enable the pipeline, it is going to create the pipeline. In practical purposes, it will take few minutes since this is a recording. Like it's much faster. But ideally, like once the data starts flowing, right? So from the time you enable the VPC flow log of the processing, the any incoming logs will get processed and converted into OCSF format and dumped into the same CloudWatch logs as a destination. So you can see the configuration here. And if you go back to the actual log group now, so this is the VPC flow logs I just configured. And if you look at the format, right, this is basically in the OCSF format here. So I'm going to pick the latest one and see what's in my format. So if you notice here, this is not like the regular VPC flow logs. This is in a OCSF format. So if I pick something Volt, so you could notice here, like the data is actually this VPC flow log format, right? So the key thing here is like since the time you enable the pipeline, it will get converted into OCSF format. Yeah. So and one other thing is like now you want to enable these flow logs across your organization. So you don't want to do it on each account level or now this is something CloudWatch added recently, wherein you can actually enable the collection, telemetry collection, by enabling a enablement rule for the supported services. So in this case, VPC flow logs again, you could specify whether you want to do it on the account level, organization level, or the OUID level. And then you also can add, like, you don't want to collect VPC flow logs in, probably you don't want to do it with test or dev environments. You could specify a tag saying like, yeah, if there is a tag, then only start collecting the logs, right? And then this is the location where you want to collect the logs. And here is an option for you to pick some of those fields. So if you want to include or exclude any fields that you can choose from there. right? So once you enable this, like this is going to have not only the existing VPCs with the tag. If you create any VPC in the future with the tag in place, it will start collecting the logs, right? And then let me take a quick pause here, right? So we talked about so far we talked about the foundation pieces where we centralized the logs, we created the pipelines to convert the format, and then the third piece here is to enable telemetry collection across the organization. And then the last one is this database insights, which I'm going to talk about, explain that more in detail. But let's see that in action here, right? So one thing, like, yeah, you have the foundations, and then like, yeah, take advantage of the out of the box insights that AWS provides. One of the things is the cloud database insights, which will give you a cross account, cross region capability, right? So you can monitor the instances running cross account, cross region from a single location. So in this case, I have selected multiple accounts and multiple regions, and it lists gives me all the databases that are available on these accounts. Yeah. And when I go to the and these are the out of the box insights that are available without you having to create any dashboards and whatnot, right? And it will give you the top SQLs and the queries that are waiting for longer duration, and also the metrics that helps you with identifying your CPU workloads, or if there are any connection throttling happening and whatnot, right? And then you can switch between the accounts to see the details that you wanted to look into. And then similar, like this is for database insights, and similarly we have container insights, which gives you the details required for understanding the ECS utilization and some of the common metrics. And the same thing applies for Lambda insights as well, to identify any cool starts and whatnot. Yeah. Okay, so this is the demo that I have for today, and now let's go back in here. Yeah. All right. So we have seen how having a right foundations is very important to have observability that scales at enterprise levels. Now let us see how we can add some intelligence to it and improve the operational excellence using some native CloudWatch features as well as partner tools like NeuBird. So AI-powered anomaly detection, right? So this is where like machine learning transforms observability from reactive to proactive. So for metric anomaly detection, CloudWatch provides ML baselines with seasonality. So this basically is where the system learns your normal patterns, including daily, weekly, and seasonal variations. And then the custom and AWS metric support works with any metrics that you are collecting, right? And then the automatic outlier detection. This identifies the anomalies without a manual threshold setting. So for log anomaly detection, it has 5 different anomaly detection types, starting from frequency changes all the way to new error patterns. It detects any when a normal log pattern changes, or alerts when completely new log pattern appears and whatnot, right? And then with the distributed tracing anomalies, you can detect when service interactions change unexpectedly, right? So it can identify the performance degradation patterns, connect errors, error spikes across services and whatnot. So so let's talk about the deployment strategy here, right? So we talked about the pillars and how do we what should be the deployment strategy. So the key is like taking a phased approach, right? So you don't want to try to do everything at once. So at the phase one, which is foundation, like a configuring monitoring account, setting up log centralization, establishing the retention policies, deploying your alert framework, and getting your tagging standards in place. And this gives you immediate value and as well as centralized visibility and basic alerting. And And then the phase two is the insights, right? So as we have seen in the demo earlier, CloudWatch automatically provides deep operational insights across your entire stack with minimum configuration, be it container insights, which monitors EKS, ECS parts and services, and as well as the resource utilization and performance metrics, and then the database insights that tracks RDS query performance and connection pools and even some optimization recommendations, right? And then Lambda Insights analyzes the functional level metrics, including the cold starts and the memory usage, all integrated with distributed tracing for complete visibility. And then the third phase is the application performance, wherein you want to enable application signals for automatic instrumentation and turn on the transaction search, right? The transaction search captures 100% of your traces. So every single transaction, every customer interaction, every API call, nothing is lost at the sampling. Right. So when you need to investigate a specific customer issue or troubleshoot a rare edge use case or that may happen, you know that the transaction data is there to dive deep in. And then you want to implement SLO tracking and set up the real user monitoring and synthetics, right? And and then the advanced analytics part is where like yeah, using contributor insights for high cardinality analysis. I briefly talked about it in my initial slides, but let me take a minute to explain this here, right? So typically, traditional monitoring systems collapse under high cardinality data, right? So this is like millions of unique metric combinations from be it like customer IDs, transaction types, and regions. But CloudWatch Contributor Insights solves this by analyzing logs in real time instead of creating metric explosions, right? So it gives you automatic top N rankings without cardinality limits. And then the metric insights for scaling alarming, right? So basically, traditional alarm management collapses at enterprise scale, manually. So if you have to manually create and maintain thousands of individual alarms with inconsistent threshold across the teams, this is going to be a nightmare, right? So, but CloudWatch Metric Insights solve this with SQL-like queries that let you monitor entire fleets with a single alarm. So you could further use tag-based filtering to automatically include new resources and centralized analysis to understand patterns across your infrastructure. So Amazon have CloudWatch investigations, which can be used for AI-driven root cause analysis. And you could further deploy SSM runbooks for automated remediations and so on, right? And finally, the optimization. So optimize the cost and performance based on the actual usage, right? So you want to use composite alarms to reduce the noise and implement embedded metric framework for efficient telemetry, and also optimize the log retention based on your business requirements. So this phased approach gets you from a traditional monitoring to AI-powered observability systematically, right? So start with the foundation, add intelligence, and then optimize it. So each phase builds on the previous ones, giving you immediate value while progressing towards the complete blueprint. So in addition to this, having partner tools like NeuBird AI SRE agent, which transforms CloudWatch alerts into autonomous incident resolution and automatically investigating the root causes, correlating signals across the monitoring tools, and delivering actionable fixes 24 by 7 without manually troubleshooting sets you up in the right direction to handle the scale. So now let us see how this works in action. Over to you, Bennett.
Thank you, Kishore. That was an awesome demo of AWS CloudWatch, all of the new features that have been added, and really how to leverage that to optimize, observability pipelines and platforms. I'm going to talk a little bit about NeuBird, what is AI SRE, and kind of some overlap with how to use the CloudWatch best practices to set up an AI SRE for success. So NeuBird AI, who are we and what is AI SRE? Well, NeuBird, we have kind of a couple core features in our platform in terms of how we do AI SRE. We do alert triage and processing. So you
Yeah.
can think about this as rules-based incident response, taking either, natural language, things like wanting to investigate P0s, P1s, P2s, this kind of thing, as well as, looking at the alerts that are coming in, um, maybe even the anomaly-based type alerts we saw earlier with CloudWatch. Kind of going into the middle of the life cycle as an SRE is the RCA and reporting standpoint. So our LLM-based system will build the queries and test the hypotheses around uh, CloudWatch, looking at alerts, looking at metrics, and looking at the various different telemetry sources that you may have in AWS and otherwise. And ultimately, we combine those to land on the root cause. So, what actually happened between your code and your infrastructure to cause this alert or cause this outage? And kind of going full circle here, we have infrastructure intelligence and MCP. So, a lot of our customers don't just want to respond to observability and respond to alerts, but they actually want to be getting smarter and optimizing how they configure both their applications, their infrastructure, and the alerting process itself. So as part of that, we support the more open-ended prompts using our proprietary context and view of your infrastructure to answer these questions that other systems may struggle with. And we also can plug into your development process by using our MCP. So this is a lot on this slide, but thinking about everything that we do, how we connect, and what the process looks like, is we're really trying to move site reliability and the SRE engineer from a more manual process of incident response and remediation to being more autonomous. So we'll take, all of the telemetry and inputs and do the triage of the alerts as they come in, as well as this RCA and follow-up. And what we see here is a lot of benefits in terms of helping you cover different shifts. For example, you can think about people who have multiple time zones. Kishore talked about multi-account, multi-region. There's a lot of benefits to having this autonomous incident response. And as we see here, we're supporting everything with AWS when it comes to telemetry and infrastructure. So let's talk about some of the problems and solutions that we're seeing with observability. First one being, alert fatigue, reducing noise and trying to restore signal. So I know as my experience as an SRE, a lot of time was spent responding to pages, acknowledging the same alerts that we knew were false and kind of doing a lot of tuning around that. We see this as we increase the amount of telemetry. Alert fatigue overwhelms the operations and processes, and we see too many false positives and low signal alerts. And this can slow down the MTTR or the time to resolution. Context switching is expensive and challenging, especially as SREs are supposed to be software engineers as well. Going back and forth between coding and dealing with alerts has its cost. So talking more about the solutions, right, is, Kishore gave us a bunch of good overviews here, but some in summary are, setting meaningful thresholds, getting up to, composite alarms and having more contextual awareness and implementing the pipeline of suppression, deduplication, leveraging these newer features in AWS like anomaly detection and helping you reduce noise in that way. And overall, it's just about creating actionable, context-rich alert descriptions. And when we think about AI SRE again, this context is critical, and it helps us get to the root cause faster and more efficiently. By the numbers. So we see some pretty interesting statistics about alert fatigue. Over 60% of observability practitioners who see alert fatigue reduction, they see it as a key objective. Um, we're always hearing it from customers. It's a big part of our app that we'll see in the demo, and it's not going away. 27% of alerts are ignored or not investigated. So this is once again just going to say that there's a large portion of this that can be tuned that, if we're able to reduce that, that's a big win off the bat. And 33% of engineering time is spent just in the incident response and firefighting component. Now, this may be more normal for a centralized SRE team, but there's a lot of development teams out there as well who are spending their time doing this incident response and not working on bug fixes and product updates and other things. Looking at the next problem, MTTR and the age of microservices in distributed systems. I know from my time across working at larger companies as well as startups, our systems are getting more complex, especially with some of these newer architecture patterns. So we see this, they get more complex. The monitoring is hard to scale at the same speed as adding all of these services. And there's a lot of manual correlation in the root causing and just a general difficulty of building the true visibility that Kishore is talking about, where we want the business impact and kind of this composite overview beyond host monitoring and host metrics and kind of the fundamentals. So some of the solutions here, we can use distributed tracing, whether that's open telemetry, X-ray, using service mesh, often gives you a lot out of the box if you're in the Kubernetes environment, and then automating correlation and using these AI tools basically. So if you want to turn it on and basically get some help for deduplicating and finding and searching more data across alarms and metrics than you could manually, then AI SRE is very relevant. Google came out with their 2025 DORA report saying more complex architectures are cited as a core factor in making incident detection and resolution harder, increasing MTTR. This is pretty clear to most of us, but the important thing is that with AI and all of these newer systems is that this is a trend that's been going on for a long time, but it's still continuing. So we have to come up with some new solutions. 3, cost optimization, always important. We touched on this earlier as well, but you can't just add more data or more telemetry to the problem. There is an inflection point where that may help early on, but for enterprises and more complex operations, we have to be more strategic and intelligent about how we add telemetry and how we sort it. So, we see Grafana Labs, huge observability provider, stated on average, orgs are spending about 17% of total compute infrastructure on observability and tooling, and at least 10, being the most common response. So this is a significant portion of your, application and infrastructure spend. So it's important to optimize. Looking back at some of the problems now, not all telemetry is the same and created equally. We don't really want to process low signal. Sometimes we need it just to have data that can be normalized, but we don't want to process it through the pipeline. CloudWatch costs scaling with ingestion volume, so we just want to be careful on, once again, what we ingest and make sure that it's kind of high signal. Storage and query costs, we talked about traditionally sometimes having issues with too much cardinality. For example, Kishore did present, there's some newer solutions there. So we want to make sure that we're using kind of AWS best practice and the latest features to not run into that issue. and just overall struggling with explainability and knowing what the observability is measuring. So some solutions here, using the pipeline for observability, filtering through, using the metric filters, sampling and using the statistical side, setting your retention policies, and ultimately, oftentimes a faster solution here is to use an AI product that can sort through and find some of the signal um, with the same, amount of data, all things held equal. And finally, four, bring it all together, the pyramid of observability, get the foundation right and amplify the signal. So we've touched on these problems with, finding the insights, deduplicating it, and ultimately trying to have observability that reduces MTTR. Uh, but how do we do that? So we start at the foundation, we get the CloudWatch best practices implemented. We layer, so we start to add more context. We go beyond just host level or infrastructure level metrics, and we add, tagging or namespaces or tracing and kind of other components to it. And ultimately, we aggregate and we build composite alerts, and we bring in kind of all of this process together, and ultimately, you know, reference this with additional tooling. So NeuBird, Hawkeye, AI SRE, right? How do we bring this all together? So we're able to ingest the CloudWatch metrics, the logs, alarms, traces, all sorts of different data, as well as your configuration data, which is often a component involved in RCA that can be missed from, an observability platform or provider by itself. We correlate this across AWS and help identify, anomalies, signals, and provide you with the RCA in the context of actually how we did it and kind of, the beauty of it being an AI SRE agent and running in the background is it can do this 24 hours a day in the background. It's going to be the first to, quote unquote, respond to the page and kick this process off. So now let's switch over. Let's do a brief demo of NeuBird, the Hawkeye of the product, and how it actually links up with AWS. So coming into the platform, similarly, organizationally, we have ways to logically separate our projects and our work, our services. Kishore mentioned being multi-account. All of this is supported. And in our platform, we do this via connection. We can add multiple AWS connections, whether they're different accounts, regions. All of this is supported. This is read-only. We don't store any of your observability data. It's only used during the RCA process and not stored. And what we're able to consume is everything that we mentioned earlier, the metrics, the CloudWatch logs, the AWS config service is, very useful for seeing when infrastructure changed and how it changed. Traces, whether it's X-ray or using, open telemetry and Tempo, Amazon managed Grafana, Amazon managed Prometheus. All of these things are able to come through as a source. Now, when we have multiple connections, and we may also have, thinking about NeuBird, our customers will have connections and resources across many different platforms. And I know I've experienced this pain myself as an SRE. There's a lot of different tooling, and teams are either ongoing a migration or considering a migration of some tooling and some observability product seemingly at all times. So we support a lot of different connections and we're able to correlate that back to AWS. For example, if an application runs components that talk to each other in different providers and have kind of disparate observability, telemetry, and data. So wrapping up all of these connections, we can put them into projects. This is where we ultimately organize our work, and this is where we can run, our RCAs and set up this component. So if we look in here, this is the dashboard. And if I'm an incident commander and I'm trying to use an AI SRE product, this is what I'm looking at. So I have alerts and incidents that come in. If prompted to, Hawkeye will automatically investigate it on my behalf. And I can also go back to that idea of infrastructure intelligence and being a developer. If I want to ask open-ended questions about my infrastructure, I can prompt it to. For example, earlier we saw that I ran a prompt that was about recent CloudWatch alarms. Let's just take a look and view this. So, referencing here, we see that we were able to use the AWS connection and read the state or status of our CloudWatch alarms. We see different states, whether it's okay, insufficient data, all of these exist, right? And I've seen these many times before. So not only can I get an overview of what's the system status, of my services, or if I'm a centralized SRE team, all of the services that we're supporting in this account. I can even follow up and ask, when did these change? Is there any correlation that I've done? Um, and best practices. So going back to some of the things that Kishore mentioned with how to properly enable and use CloudWatch to its maximum, I can ask Hawkeye about this, about is my log retention set correctly? Do I need to export anything? Uh, how can I configure this based on previous incidents? So we see all of this. We see recommendations for triage, we see follow-ups, and this is just an open-ended prompt. Going back here, we can actually run ad hoc investigations, which I'll kick this off and show you one that's already run. But let's let this run. It's going to query AWS. It's going to query the different providers for telemetry and actually correlate in RCA. All right, going back, let's take a look at an image backoff. So this is a common example as an SRE working in a Kubernetes environment of something that you might see. Someone may introduce a config change from GitOps, or maybe you're using Argo CD and the image is not available. What we see here on the right is the chain of thought. This is where Hawkeye is forming hypotheses and it's testing across many sources. So the product is very explainable in terms of where is the data coming from, how is it reasoning about it, and we have a lot of clarity in terms of how this process works. So not only are we running within EKS and doing kubectl and using those read permissions to actually read, but we have the AWS config. We have the metrics from CloudWatch, we have the logs, and Hawkeye is correlating all of these. In here, we can actually click in and we see the different process of how it's investigating and how it's using those different sources. This is really helpful when you think about the scale of all of the telemetry that you have, because behind each one of these is it's not just reading every CloudWatch metric or every CloudWatch log, right? It's actually determining based on its own hypotheses where to look and how to do it. So kind of moving on to the last step is, it'll give us not only the RCA, how to do it in your account, but also what improvements can we have? Uh, what's the overview post-mortem style? How long did it last? And ultimately, what everyone cares about, how much time did this save your team? Because if I don't have to answer a page as an SRE and I come in and I get the RCA and know exactly what to do, that's really useful. So let's go back now and see what additional resources we might have on the AWS side, kind of following up from this. And I'll hand it back to Kishore.
Yeah, thanks, Bennett. That's wonderful. Driving the RCAs and coming up with the action plan. It looks pretty neat. So here are some resources, right? So the so all, I know we had a very little time to talk about all the features in details, but yeah, we have those features captured as the interactive demos. So if you scan this QR code, get into the portal that takes you to uh, demos that you could play with and see them in action. And then there is this one observability workshop, which is publicly available that you can set it up on your own environment and try it out. Uh, Alternatively, if you have a AWS support, oh sorry, AWS contact, be it a TAM or a SA, you can take their help to set up a test environment for you. And then the Cloud Operations show is the show that our team runs, which talks into details of each and every feature, and also shares some customer anecdotes and some real use case scenarios there. So I highly recommend to take a look at it. And then, of course, the best practice guide I talked about, most of the things I talked about are briefly explained in there as well for additional details. Yeah.
Great, thank you. That'd be very useful. And if you're interested in learning more about NeuBird's AI SRE and our product and some of the additional features that we didn't get to today, you can do a 14-day free trial at our website and take a look at our landing page on the AWS integration and how we do everything with CloudWatch. And thank you very much for coming to our webinar.
Yeah. Thanks for taking time to join this.
Thank you.